Have you ever found yourself stuck with a compiler error that just doesn't make sense? It can be incredibly frustrating, especially when you're trying to implement smart pointers in your C++ project. If that sounds familiar, you're in the right place. Today, we're diving into a common issue with using unique pointers in vectors. I totally get it. Compiler errors can feel like a brick wall when you're just trying to make your code work. You're not alone in this. Many developers face similar challenges when working with smart pointers and vectors in C++. It's a common hurdle. Let's take a closer look at the specific issue at hand. One user recently asked, "Why am I getting compiler errors when pushing a state object with unique pointers into a vector?" They described their setup with a class structure for a discrete simulation, and they were confused about why their code wasn't working as expected. Sound familiar? Let's break it down together. So, what's going on here? The issue arises because the vector is trying to make a copy of the state object, which contains a vector of unique pointers. Since unique pointers cannot be copied, this leads to the compiler error you're seeing. Understanding this is key to resolving the problem. And stick around. At the end of this video, I'll share a pro tip that will help you manage smart pointers more effectively in your projects. To resolve the issue with adding state objects to the vector, the user should consider using a vector of unique pointers to state instead of a vector of state objects. This way, the user can manage the ownership of the state objects without copying them. Next, the user should modify the loop where they create state objects. Instead of creating a state object directly, they will create a unique pointer to a state and then add it to the vector. Now, the user should ensure that the add transition method in the state class remains unchanged. This method will still accept unique pointers to transition objects. Finally, the user can test the updated code to confirm that it works without any compiler errors. This approach will allow the user to manage the state objects effectively while maintaining polymorphism. Fun fact, did you know that the concept of smart pointers was introduced to help manage memory more effectively in C++? They help prevent memory leaks and dangling pointers, making your code safer and cleaner. Now, let's look at the answers provided by other users. This user suggests making an ownership decision regarding your unique pointers. If the vector owns the objects, you should move the unique pointers into the vector and access them through raw pointers. However, be cautious, as they may become invalid if the vector is destructed. Alternatively, if the vector does not own the objects, consider using a vector of raw pointers, but remember they will be invalidated when the unique pointers are destructed. For complex relationships, using shared pointers might be beneficial, but avoid circular references. The user concludes that a state likely owns its transitions, so continuing with unique pointers in a vector is advisable. Let's take a moment to review another user's answer. This user suggests that to push the end-state object into the state's vector, you need to use stdmove. Since the state class contains a vector of unique pointers, which are movable but not copyable, the entire state object is also movable. Therefore, you should use stdmove when adding it to the vector. Additionally, the user recommends marking the state constructor as explicit to prevent implicit conversions from int. They also suggest using stdmakeUnique for creating unique pointers, which is a cleaner approach introduced in C++14. Now, let's dive into a different answer from another user. This user suggests avoiding the pushback method and instead using emplaceBack to create items in place. This way, you can add new states to the vector without copying or moving existing objects. They also recommend reserving space in the vector beforehand to improve performance. This approach allows you to efficiently add transitions to each state without running into copying issues. That's it for that response. Let's explore another one. An alternative solution provided by a user suggests implementing a move constructor for your state class. This allows you to move the state object instead of copying it, which resolves the compiler errors you encountered. Let's take a moment to review another user's answer. An alternative approach suggested by a user involves passing the unique pointer by reference in the add transition function. This way, you avoid creating a local copy and don't need to use std move outside the function. Additionally, the user recommends using std make unique transition instead of new transition. This encapsulation helps make your code clearer and reduces the risk of memory leaks. Here's the pro tip I promised. Always prefer emplace back when dealing with objects that cannot be copied, like those using unique pointers. This small change can save you a lot of headaches in the future. And there you have it. By using emplace back, you can avoid those pesky compiler errors and keep your code running smoothly. If you found this video helpful, don't forget to subscribe for more coding tips and tricks. Happy coding!